Good morning, mathematicians. How's everyone doing? Um, I do wonder, partly I should figure out a different microphone configuration. So maybe I realize there's a lot of mouth sounds that come through on the recording. And maybe that's not ideal. I do wonder, partly I should
I
figure
was
out
thinking,
different.
I do like slurping my coffee, ASMR coffee. As annoying as that might be. But also, yeah, maybe this channel would be better with less mouth sounds. um. So, what are we doing? Well, first, I need to correct something I said yesterday. I said something a little bit wrong. Hello, Kostaka Corey. Slurp Master 6,000. Only 6,000? Where are we here? So yeah, first I want to correct something from yesterday. So oh, by the way, new video dropped about Gawa representations from Lozano Robledo. So definitely go check that out. Yeah, what was I gonna say? It is office hours indeed. Hello, Jacko. Yeah, so the dimension, right, in general, the dimension of an induced representation will be, I guess, the order of G mod H, right? The index of H times the dimension of V. I'm assuming complex, right? Just to make life easy. Well, I don't think that even matters here. It should be true in any, yeah. So, so what? Well, this gives us a partial answer. I mean, for these semi-direct products, we concluded that basically the dimensions of representations we're going to get. Good morning, tenacity. Wait, why are you highlighting morning? Are you now in a place where it's morning at this time? Weren't you in Europe or something? So if we induce, right, we're here V. V is going to be some representation of the stabilizer of G. So that's all the representations are going to look like this. Basically, where V is some representation of the stabilizer acting on some characters. Hello, Sergio Polar Bear. Hello, Noel. You usually have no clue what I'm doing, but you like saying hello. Well, I also appreciate you saying hello. You like analysis and topology. Wow. We do occasionally get into some analysis and topology, but I can't deny my true algebraic nature. Good morning, Arad. So, I made the coffee a little strong today. I'm gonna be wired at the end of stream, which would be good for productivity, maybe. Except actually, I'm going out, so it's like a waste of energy. Yeah. Joining the hello despite your lack of understanding crowd. Yeah. Hello, Sawdust Creator. Hello. What are the prerequisites for studying Ricci flow? I don't know, but there is this book. There is a book. I shared it with someone in Discord recently. I mean, there's a lot of books now that there's a lot of books now talking about the proof of the Poincare conjecture. That there's some big one. Yeah, so maybe something like this is complete proof of the Poincare conjecture, or no, maybe that wasn't it. There was some I found some like 300-page PDF that was like, here's all the background you need. Oh, now I don't remember what it is. Oh, maybe it was this one? Since this one is, I've clicked on it. I don't know. Oh, wow. Okay, what do we got lots going on in chat here. I don't remember which side the alligator mouth goes on for semi-direct products. That's easy because, that's easy. I mean, it annoys me to no end when people do it this way, but whatever. I guess there's some justification for this in certain scenarios, but the way I remember it is like a normal subgroup is like this, right? That's our notation for a normal subgroup. And so the semi-direct product, it's still, you think about the triangle still like points towards the normal subgroup. That's sort of how I think about it. Topology goes quite well with algebraic nature. That's true. But, we're not... how often are we getting into the weeds of topology? I mean, we talk about a lot of algebraic topology and homotopy theory, but it's maybe not as into people... the left adjoint view and the homotopy quotient view are both in an overflow post, but it won't let you post it. What's the title of the overflow post? What's the title of the overflow post? You read about adjoints in Leinster's notes. Thanks for recommendation. You're welcome. This is you reporting back from a few days ago. Good. And things make more sense now? More clear? Are semi-direct products categorical colimits? Nikolai, still learning probability theory. Well, good. What's the probability you'll know it all tomorrow? Can you compute that yet? I've clicked on this one before. Products are very elementary forms of categorical limits. The question is whether, in the category of groups, semi-direct products are categorical limits. As was pointed out here, gives a universal property. Right, Bourbaki gives a universal property. And in fact, actually, I think we've looked at this post on stream before. To be honest, semi-direct product is not a limit, but rather a co-limit. Right, and actually, I even opened this one the other day again after the 92%. Damn, that's pretty high. And you came back with that answer quick, so I believe it. That tracks with such a high percentage. Oh, maybe it's the Clay Institute's book that I was thinking of. You'll actually remember the semi-direct product notation now? Hell yeah. Used to just write whatever and hope it's correct, yeah. Projective Spaces live stream one? Maybe we could talk about it a bit today. I have some very old videos on projective space, like the first or third video I ever posted on this channel is about projective spaces. Yeah, the quotient is reaching out its hand sacked on the normal group. Yeah, I like that too. Still don't get what limits are. Well, now you have Leinster's notes. I'm sure you noticed that there's a bunch of stuff about limits there, and you already know a bunch of examples of things that are limits. You just don't realize it yet, like products and unions and stuff like this. In group theory, you do not understand the relation. Well, just, look at some examples. Right? So, what happens if we first, let's say this is our diagonal, right? So first we apply S, then we get 1, 3, 2, 4, and then we rotate 90 degrees, so we get 2, 1, 3, 4, and then let's say we apply S again, and we get 2, 4, 3, 1, right? And now notice, right. Notice this is exactly the same thing as if you rotated 90 degrees this way instead. So yeah, that's why it's like that. And this holds in general. So okay, there's your first example, but if you just think about what should happen, or you can also think about it as like SR is R inverse S. Just think about for a polygon. Just think about what happens if you rotate and then flip. And then consider flipping, and it's going to be the inverse rotation, more generally. Am I familiar with the orbit method, which relates cojoint orbits to irreducible representations? Not only am I familiar with it, well, I'm actually have been sitting in a reading seminar, this semester, about the orbit method, and I have here Krylov's book on the orbit method. I'm certainly not an expert. I know a little more than I did previously, since sitting in on the seminar. But yeah. Yeah, it's very cool. It's very cool. Maybe one day I'll talk more about that on this channel when I understand it better. Okay, so I'll talk about projective spaces in a moment, possibly for Sawdust Crater, but I might also get distracted by the impossible task of keeping up with chat. Product is a co-limit, make it make sense. Well, it's not a limit, so orbit method mentioned. Hell yeah, we love our orbit method here. Very, very cool. Very, very cool. When you were late because you're doing geometric algebra, that's forgivable. I'll forgive you for that. Busy now, so in, out, but am doing the set theory symbol tier list today. And upon thinking about it, you think delta for symmetric difference. Wow. I'm not watching your slop. Saw a nice measure theory problem today, which needed symmetric differences pretty centrally. Yeah. Yeah, but I mean, I don't think Leo's upset about symmetric differences, but more so the notation for them. But what's your proposal for the notation then, Leo? What do you prefer for symmetric differences? Um, you think A is on the left because we usually write short exact sequences from left to right? No, but people do like so. Yeah, you have something like this, but people will write it this way. So the notation, I mean, this is still correct, and the notation still suggests to you that A is the normal subgroup. Um, but like I think people do this. Am I doing it the right way? For like, if you decompose a parabolic into its Levy subgroup and its unipotent part. Well, I think this is. I think the reason is, I could be wrong, but I think the unipotent part is the normal subgroup. The unipotent part is the normal subgroup, but normally we write our matrix decompositions with the Levy factors on the left. So this is sort of the justification for why I think people write it in the opposite order. But I like people definitely do this. I mean, these two statements mean the exact same thing. It's not about the side that the A is on. Yeah. That is your only useful example. Huh? Mu A delta C less than epsilon? What? What? It's pretty useful, yeah. And I mean, the other thing that's cool about the orbit method is the idea. It's sort of there's an idea that's supposed to be related to quantum mechanics. So basically, what is it? The idea is that normally you have like some classical system which you should think of as being symplectic. So you should be going from symplectic spaces, and then quantizing basically takes you to some like Hilbert space. And the idea is the same thing, is that this is like your coadjoint orbits have a natural symplectic structure, and they're supposed to be capturing like unitary representations, which of course is like Hilbert space stuff. So there's like this analogy here. So saith David Vaughan, and I trust his opinion on such matters. Are we still searching for the CELO? Sort of. I mean, I started off stream talking about this a bit. I mean, I corrected an error from last time, but this still isn't great, right? I mean, this is really highly dependent on context. It doesn't really give us a way of like a very general condition on where, like, let's say for a prime, that you could guarantee that a group has a representation of prime degree, right? Like we saw a pretty general, like from that paper, there's a pretty general conditions under which we can say, oh yeah, a representation or a group will have a representation of an irreducible representation of dimension 2. But we don't, it'd be nice to say something about like prime powers or something more generally. And I just don't know if we'll be able to get away with it, right? Because like the dream with what we know about the Abelian group case, the remaining hope would maybe that we say something like, suppose G, like let P divide the index of the center in G, and suppose G is non-abelian. Then could we say that there is an irrep of order P, of dimension P? Probably not. Maybe we should go look at some character tables or something to start. But I doubt it. So, like, what else do we try and do? I mean, the representation theory of the symmetric group is worked out very well, but that's like a very specific kind of class of group. So, but maybe you could say something about like groups that embed. No, I don't know. So I'm kind of at a loss for where we go. Maybe there just isn't a good CeeLo analog beyond the few things we've already mentioned. Measure theory is kind of a bitch. A mathematical accident, if you ask me. No. Petition to make all... Actually, hang on a second. You kind of lost me with the first sentence. I mean, measure theory is important to my research. I like it. And representation theory of, like, locally compact groups. Measure theory is very important. But... now you're kind of spitting with this petition to make all of PR measurable. I mean, well, I don't have to explain to you. You know, there's worlds of mathematics where that's true. Yeah, this is the dream, to be so far behind chat that I can't even answer all the questions. This is kind of the dream. I mean, some people consider measure theory a subfield of set theory. Some people do. Because there is stuff about measurable cardinals and whatever, but that's a very different flavor than how I use it. Just so you don't spend another 5 hours on this, does someone know how to translate a point in two-dimensional CGA? Commutative geometric algebra, is that? What do you mean translate a point? What do you mean how to translate a point? Open YEK and tell you what looks like measure theory? Here's Herbacic and YEK. And where is it here? Let me bring you guys along for a ride here. Actually, maybe I'll make the camera bigger too. Yeah, look at that beautiful face. There we go. The measure problem. Boom, 241, large cardinals, the measure problem. Right there. So, there you go, Boris. Although, technically, it wasn't... your challenge was to open up YEK, and I opened up Herbacic and YEK. So, perhaps my challenge to you was unsuccessful. I don't know. What are your standards, man? I don't know why I did that. I have a digital copy of this book. I could have opened it up there, but it's more fun, right? Got to keep stream dynamic. You know, they say you should be, cutting your video every like 30 seconds or whatever it is to keep you guys entertained. Just hypothetically, if I had to do a seminar talk on the geometry of the upper half plane, the modular group, and elementary properties of modular forms, what would be your focus? Well, I have some old videos on the modular group and SL2Z acting on the upper half plane, but I didn't even really get to modular forms. Yeah, depends on the audience and what exactly it is, but I think part of why I wanted to make that video was to come up with a plausibility explanation for myself of why the transformation property of modular forms is what it is. Like when you first encounter it, you're kind of just like, okay, why would I consider such a thing? And the sort of the goal of my video was to try and make that a little bit more plausible, and for me that was sort of through going the like scaling lattices approach. I don't know. How even would measure theory be a subfield of set theory? Well, I kind of answered that one. Borel hierarchy, measurable cardinals, sigma algebras, yeah. Quite set theory E. Everything's set theory, that's true. Yes, but there is a vibe to things. Yeah. The motivation of measure theory is AOC difficulties. I don't know. I don't know how much I would agree with that. The motivation for measure theory is measuring stuff, namely taking integrals. But then, yes, it branched off to set theoretic things. I mean, in my opinion. What book do I recommend for advanced linear algebra? Well, you could go look at the classification of PIDs in a Luffy. Modules over PIDs in a Luffy. I mean, that kind of counts as advanced linear algebra. Oh, and I see Jacko beat me to that recommendation. You think there's an argument for measure theory beyond it being bookkeeping method? Yes, I mean, doing integrals. Like, what are you talking? I mean, how do you do harmonic analysis of groups? You can't, like, the measure theory is important here. And decent language for probability theory, yes, of course. Like, how is there any debate to this? Wow, I'm so far behind chat. Well, this is just going to turn into me reading chat all the time. I won't even be yapping. Got to read faster. Everything you say is gospel. Fair enough. You were thinking maybe instead look at a vector space of set dimension and see what groups could be represented in that dimension. Oh, you know what? I did have a thought the other day. No, what was I thinking about? No. I was out for a jog yesterday, and I was just thinking about how to prove the converse statement that every representation, or if you have a group and you know that every representation is one-dimensional, then the group is abelian. And I had the thought that, well, if you can just prove, if you can just establish the existence of a faithful representation, which is to say injective, and then argue that it's one-dimensional, and then because it's faithful, it's an isomorphism onto their image, and these are all scalar matrices, so the original group must be abelian. That was a thought that I had. Yeah, but I'm not sure. I mean, this is basically just another way of phrasing the same question, Locke. So, GLCN would be classified? What do you mean? So we could look at the possibility of maps? Yeah, but that's such a huge possibility. Like, that's extremely complicated. That's extremely complicated. I guess maybe that's extremely complicated. On the other hand, for for representations in finite fields, I guess there's finitely many matrices, and there's like finitely many conjugacy classes and finitely many matrices, and so maybe there's something to your approach in the finite case, but yeah, I don't know. Yeah, to be honest, measure theory was my gateway drug to considering maybe I wouldn't mind being a finance boy, a rich finance boy. Because all the probability theory stuff. Conformal geometric algebra? I don't know anything about that. Have you asked the point nicely? Yeah, think about that. You never looked at big set measures. Speaking of, there's a paper slash note called Zornian Functional Analysis, which lists a bunch of, fair to argue, ugly statements consistent with ZF plus not C. Yes, I think there's also some good. I think I found a Stack Exchange post once, and it was maybe possibly even an answer by the set theory goat, Joel David Hampkins, about a bunch of ugly statements. I mean, the real thing, you're damned if you do, you're damned if you don't. The real thing is to just reject C and not C. Just ignore it. That's the real move. Oh yeah, Rotman. I've never looked at Roman. Oh yeah, Rotman's algebraic topology. I've never looked at Roman, so I can't suggest it myself. But pirated prints are dirt cheap. Yeah, fair enough. But there's nothing like the real deal. Come on. You're off? Alright, well, see ya. Wait, the P word? What's the P word? Who said the P word? Plagiarize? The modular form definition is a cocycle property. Ooh. Ah, right. I do remember. Oh, that's a better way to explain it, actually. I think that now that I'm older, I think that's a more interesting way to explain it. Yeah, I remember reading up once about looking at something about modular forms and line bundles on the modular curve, but I didn't understand it at the time. Now that I'm all grown up, I could probably understand it. So, modular forms as sections of line bundles. That's probably a way better way to understand it. I'll just keep this open here. For a lot of those places where you say, oh, you need it for integrals, you can just take limits of smooth functions. What? What do you mean? What's a smooth function? What's a limit of a smooth function? Let G be a locally compact topological group. Okay. What's a smooth function from G to C? Notice it's a topological group. There's no smoothness condition. It could be totally disconnected. It could be ZP. The probability measure for Wiener spaces is one good motivation for measure theory. Goes beyond what Riemann does to you. Yeah. Like, so you want to integrate an L2 function, you can just take the limit of smooth functions rather than define measures. But again, what do you mean by smooth functions? Like, if X is some random topological space, what's a smooth function? There's no notion of smoothness. I mean, okay, in the Piaget case, there's some, analog of smoothness, but take it more arbitrary than that. What do you mean by smooth? If you're doing hard measure stuff, no. Like what about a finite group? I mean, okay, yeah, there technically you're just doing sums, which is the counting measure. Yeah, but if L2 of M a manifold, sure. But the beauty of measure theory is it allows you to do it in much greater generality. So, I mean, that's the argument for measure theory, right? Much greater generality than the smoothness case. Hoffman-Kunz? I've never even looked at it. We should all do abstract harmonic analysis as God intended. Yeah, I kind of agree. Read a group read through of Dietmar's books on harmonic analysis 1. There's a 2020 paper called The Concept of Velocity in the History of Brownian Motion. which discusses a bit of physics versus math of it all. Interesting. Wrap this up? You're procrastinating? I do have to wrap it up. I'm going to wrap it up in like 4 minutes. Yeah. Come to think of it, what does Wildberger think of the central limit theorem? Yeah, I don't know. I mean, again, I'm sure that there's analogs of the central limit theorem. You could still talk about it in a finitist kind of perspective. So yeah, I don't think that there's a gotcha there for him, The P word for you is PIDs. Oh, you spent a week trying to grok a non-trash proof of the rational canonical form and didn't gain anything out of it except surface level module theory. Yeah. Well, did you try crunching examples? I mean, that's always the thing for me that helps me internalize stuff, is just crunching lots of examples. It's a long walk for medium payoff in this respect a lot of the time. Your standard undergrad measure theory course spends a semester to give explicit realization of L2 functions on M. I guess. But, I mean, you got to do the things you know before the things you don't. I mean, Lebesgue measures aren't even good for working over manifolds because you can't reduce to submanifolds nicely. Oh. I don't know much about that, to be honest. You'd care more about having integration map on a dense subset of a space of functions. Measures are a technical tool for achieving that. Yeah. Yeah, look, measure theory is based, and if your opinion is different, then you're wrong. So I don't know what to tell you. Oh yeah, by the way, yesterday, what were they asking about? They were asking about fusion categories. A friend of mine was asking about fusion categories in a Discord I was in. And I gave a very brief explanation. I was like, oh, it's actually pretty simple. You already know examples like representations of a group. And then he was like, I need you to explain it to be in Skibbity language. And then I copied and pasted from Claude, and it was pretty funny. Did a pretty good job. He compared it to Gemini's version. Gemini's version wasn't quite as good. It wasn't as understandable, although there was interesting examples it gave of like the tensor product of cameraman or something. Can you really think of CLT in a finitist perspective? Sure, why not? I mean, yeah. The simple piece is weird to you, and the z in the numerator is gone. What? In the... Huh? Maybe that is fine. Wait, let's see. What are you doing? AZ... Damn, I really do gotta go, though. AZ, CZ plus D. And what do? You pull out the C... I don't understand your step. Wait, where, pull the C. What happened to the Z in the numerator, though? It seems like you just dropped the C in the numerator, no? I'm confused. Maybe I'm bad at arithmeticking. Your opinion isn't that measure theory is bad. Your opinion is that the usual motivations given for it are bad. Well, I don't know what motivations you've heard, but I think they're all good. The Lebesgue measure of R as a subset of R2 with the planar measure. You once did a reading group with Discord ship posting friend. Hell yeah. On geometric measure theory. There's a lot of lack of sigma additivity going on there. Anywho, I think that's where we're gonna end it. A little bit of yo fam. So fusion categories are straight up bussin' mathematical structures, no cap. Here's the vibe. You got these objects that are absolutely rizzed up with tensor products. Like you can smash two objects together to get another object. Amazing. I love it. It's just true. It can be written, you trade the z in the numerator for some offset. Oh, what am I missing? Oh, it's a plus all of this over here. Oh, I see. I guess I misunderstood the way that you wrote it. Maybe. I see. Interesting. Anywho, yeah, that's where we're gonna end it on a chef's kiss. Immaculate vibes. As always, that describes this channel. 100.